Here we are going through delta math problems that need to be done on the computer. First, we're going to find the line of reflection methodically. So follow the guided instructions below to create the line of reflection that would map the pink figure onto the blue figure. So we're mapping the pink onto the blue. Pink would be the pre-image and the blue would be the image. The pink is the original and the blue would be the reflection. Click and drag to lines connecting all corresponding points from the figure to its reflected image. So draw lines connecting all corresponding points. Okay, so we can kind of clearly see this one maps to this one, so I'll go ahead and click on it and drag to the other point, connect it. Do that for each one. Click, drag, hold click, and drag. If you've done it correctly, it'll say plot the midpoints of all the dotted lines. So we have to pretty much count how many spaces there are, since this is kind of hard to do visually. It looks like it should be around there, but I don't want to guess. So I'll start here and I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, that half of 13 is like a 6.5. So we're going to have to be in the middle of one of these. So 6.5. So 1, 2, 3, 4, 5, 6.5. So I found it right there. Let's do the same thing for the other one. Start at one of the points, go to the other, find out how many squares or blocks it is to the next one. 1, 2, 3, 4, 5, 6. Half of 6 is 3. Doesn't matter which side you go from. I'll go from this bottom side now. 1, 2, start over. 1, 2, 3. And then the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5. 1, 2, 3, 4, 5. And it looks like they do line up. Draw a line that goes through all the yellow midpoints. Click and drag to make the line. So I'll click on one of them, drag to the other one, and that should be it. Now write the slope of the reflection line and any dotted line. So the slope of the dotted lines, we'll do that one first. So these are units from, if I'm just looking at this one from 7 to 8. So if I go from 7, my rise is 1, my run is 1. So rise and run. Rise over run. 1 up, 1 to the right. So 1 over 1 is just 1 for that slope. Also, just kind of check it's going uphill as we travel left to right. So positive makes sense. Slope of the line reflection, notice it's going downhill, so it should be negative. So rise over run. So I go down 1 and over 1. Down 1 is negative 1, over 1 is positive 1. Negative 1 over 1 is negative 1. And then I'll try it. It looks like we're okay so far. Now write the slope of the reflection line and any dotted lines, equation of the reflected line. Okay, so now they want the equation of the line of reflection. So I know the slope is 1, so the normal equation would be y equals mx plus b. M is our slope. In this case, the slope for the line of reflection is negative 1. X is our variable, mx plus b, plus b. B is the y-intercept, and we can see the y-intercept is right there at positive 1 plus 1. You are correct. Submit answer. To finish it off, and there we go. The next one, and then we got a little animation here. I think, yep, there it goes, and we can see how it reflects. The next problem, reflect figure over the line x equals 5. We're reflecting it over the x equals 5. It hits 5 at the x-axis, x equals 5. Notice it doesn't touch y. So this equation has no y in it. It never touches y. Only 5. No matter what I do, x is always 5. X is always 5. Plot all the points of the reflected figure. You may click a plotted point to delete it. So how many spaces is it from the line of reflection? This is one space, so its image is going to be one space on the other side. This one here, I'm going to go in order. 1, 2, 3 from the line of reflection. 1, 2, 3 from the line of reflection on the other side. 1, 1 from the line of reflection. And notice it should look, and it should link to in your brain how it does look like a reflection here. Yes, complete. Our last problem in this set, reflect a figure over a line, the next level. This line looks a lot like y equals negative x. It has a negative slope, it just doesn't go through the origin. The trick for these diagonals is we count from one side going one direction, and then we switch the direction on the other side. So I'll go ahead and do this closest one first. So it doesn't matter if we go to the left or go down, we count how many spaces. I'll do both so you can see it. 1, 2, 3, 4, 5. So I went 5 to the left, now I go 5 down. I switched directions on this. 1, 2, 3, 4, 5. And that looks like it's the same from that same distance to the line of reflection. Now here's what I was saying. It doesn't matter which direction you go, so let's go the other direction. That'd be straight down this time. 1, 2, 3, 4, 5. So 5 in which direction? To the left. 1, 2, 3, 4, 5. And it lands right on the same spot. Same thing for this one. Count how many to the line of reflection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Down 11 then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll just check my work. Let's go on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Check. Last point would be this one here. I'll go down this time first. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check our work, going the other way. 1, 2, 3. I'm just kind of checking my point. So let me check my point, please, computer. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we checked out. It checked out, not we checked out. All right, and that's our problems for this learning set. And be sure to kind of watch the animation. It helps things link together.